Hello and welcome to my channel, Physics with Diaz. Today we're going to talk about linear momentum and how it is conserved in a collision. What is linear momentum? Linear momentum is a physical quantity that depends on the mass and the velocity of an object. And as you can see, that is the formula for momentum. P is momentum, m is mass, multiplied by v, that is velocity. Now we're going to see two easy examples that are for momentum. Okay, so here we have the two examples. First, we have one example that is super easy. That is a 2 kilograms ball to the right at 3 meters per second. What is its momentum? Well, we use the formula for momentum, that this is very easy. That is mass, that is 2 kilograms, times the velocity, that is 3 meters per second. And that gave us 6 kilograms. And it is to the right because it is positive. If this quantity is negative, it goes to the left. This is something important to remark of momentum. Then we have the second example, that it is a little bit difficult. It says a 3 kilogram ball moves to the right at 2 meters per second. Another 1 kilogram ball moves to the left at 4 meters per second. They collide head on and stick together. Find the final velocity. So okay, we put our data, that is v1, that is velocity for the first ball, that is 2 meters per second. Then we have the velocity 2, that is from the ball that is from 1 kilogram, that is negative 4 meters per second. That means it is because it's to the left. That is why it is negative. Then here we have momentum in the initial form, that is equal to m1, that is mass 1, times velocity 1 plus mass 2 times v2. This is 3 kilograms, mass 1, velocity 1, that is 2 meters per second. Then we have mass 2, that is 1 kilogram, and negative 4, that is the velocity 2. That gave us an initial momentum of 2 kilograms per second. Then after the collision, we first have the mass, that is 4 kilograms after the collision, the mass that is left. And with the mass, we can find the final velocity. That is the initial momentum over the mass. We do the initial momentum, that is 2, over the mass, that is 4. That gave us 0.5 meters per second to the right because it is positive. So these are the two examples that are really easy. So the examples that I just showed to us, these examples shows the principle of conservation of momentum, which states that the total momentum of a system does not change if no external force acts on it. There are two main types of collision: the elastic collisions, where objects bounce off each other and both momentum and kinetic energy are conserved. Then we have inelastic collisions, like in our example, where the objects sticks together, momentum is still conserved, where the kinetic energy is lost. Usually, it is transformed into sound, heat, or deformation. Some real-life applications of momentum and inelastic collisions can be car crashes. In sports also, momentum explains how a moving soccer ball can be stopped or redirected by a player. Also, in space travel, astronauts use momentum to move. If an astronaut pushes an object in one direction, they will move in the opposite direction. Means that the principle of momentum is true. So that's all for today. I hope you know and understand not just how to calculate momentum, but also why it matters in real life. See you in the next video of Physics with DS. Thank you for your attention. Yes.